And the answer is that breadth-first search always considers the shortest path first. And in this case, there's two paths of length 1, the path from Ered to Zerin and Ered to Timisoara. So those would be the two paths that would be considered. Now let's suppose that the tie is broken in some way, and we chose this path from Ered to Zerin. Now we want to expand that node. We remove it from the frontier and put it in the explored list. And now we say, what paths are we going to add? So check off the ends of the paths, the cities that we're going to add.
Zerin is removed from the frontier and it is added to the explored list.
In this case, there's nothing to add because of the two neighbors, one is in the explored list and one's in the frontier. And if we're using graph search, then we won't add either of those.
Zerin is connected to Arad and Aradia. Arad and Zerin are in the explored list, and Aradia is in the frontier.
So we move on. We look for another shortest path. There's one path left of length 1. So we look at that path. We expand it. Add in this path. Put that one on the explored list. And now we've got 3 paths of length 2. We choose one of them. And let's say we choose this one. Now, my question is, show me which states we add to the path, and tell me whether we're going to terminate the algorithm at this point because we've reached the goal, or whether we're going to continue.
There are 3 paths of length 2. The first path is from Arad to Timisoara and then to Lago. The second path is from Arad to Cebu and then to RV. The third path is from Arad to Cebu and then to Făgăraș. Făgăraș is connected to the goal, Bucharest.
The answer is that we add one more path, the path to Bucharest. We don't add the path going back because it's in the explored list. But we don't terminate yet. True, we have added a path that ends in Bucharest, but the goal test isn't applied when we add a path to the frontier. Rather, it's applied when we remove that path from the frontier, and we haven't done that yet.
A path from Făgăraș to Bucharest is added. The algorithm does not terminate because at this time, the goal Bucharest is added to the frontier, not removed from the frontier.
Now, why doesn't the general tree search or graph search algorithm stop when it adds a goal node to the frontier? The reason is because it might not be the best path to the goal. Now here we found a path of length 2, and we added a path of length 3 that reached the goal. Now general graph search or tree search doesn't know that there might be some other path that we could expand that would have a distance of, say, 2.5. But there's an optimization that could be made. If we know we're doing breadth-first search and we know there's no possibility of a path of length 2.5, then we can change the algorithm so that it checks states as soon as they're added to the frontier rather than waiting until they're expanded. And in that case, we can write a specific breadth-first search routine that terminates early and gives us a result as soon as we add a goal state to the frontier. Breadth-first search will find this path that ends up in Bucharest. And if we're looking for the shortest path in terms of number of steps, breadth-first search is guaranteed to find it. But if we're looking for the shortest path in terms of total cost by adding up the step costs, then it turns out that this path is shorter than the path found by breadth-first search. So let's look at how we could find that path.
The path from Arad to Cebu to Făgăraș to Bucharest is the shortest in terms of the number of hops. But if we count the weight associated with each road, the path from Arad to Cebu to RV to Pitești and to Bucharest is the shortest.